Humans have reached the moon and now live aboard a space station orbiting Earth. But while billions are spent escaping the confines of our planet, one nation is taking a different approach: China. Instead of just looking up, it's also looking down, deep into the Earth. This ambitious mission aims to drill to unprecedented depths, raising some serious questions. Are they uncovering scientific truths buried beneath our feet, or hunting for the next rare resource to fuel a superpower's ambition? How far can technology push the limits before the Earth itself pushes back? In today's video, we unravel China's quest to create the deepest man-made hole ever attempted, uncover the secrets of the Earth's interior, and explore the risks and rewards of this extraordinary endeavor. Also, stick around until the end, because what we have at the later part of the video will truly shock you. Have you ever wondered what lies beneath your feet, deep beneath? Not just the soil, rocks, or fossil layers, but the secrets hidden miles below the Earth's surface. In southwest China's Sichuan Basin, a groundbreaking project is underway to uncover those mysteries. Engineers are drilling a hole over 30,000 feet deep, about 9,000 meters. That's deeper than the ocean's Mariana Trench and taller than Mount Everest. Impressive, right? But this isn't the deepest hole they're planning to dig. In the remote desert-like Tarim Basin in northwest China, another project aims to reach 36,000 feet, an astonishing 11,000 meters into the Earth. If completed, these boreholes will be some of the deepest ever made by humans. But it begs the question, why is China so eager to dig so deep? The answer lies in a dual-purpose mission that intertwines scientific discovery and strategic ambition. Think of the Earth's crust as a library, with each layer representing a chapter. By drilling deep into these layers, scientists hope to uncover ancient stories, how the planet formed, how tectonic plates shifted, and perhaps clues about the Earth's seismic future. It's as if they're peeling back the layers of time, 1 meter at a time, unlocking secrets buried for millions, even billions of years. But there is also a strategic dimension to this venture. Beneath these ancient layers could lie enormous reserves of energy, oil, gas, and other valuable resources. Imagine the implications of tapping into these hidden treasures. For China, this could mean securing energy independence and fueling its rapid economic growth for decades to come. This dual mission, scientific exploration and resource acquisition, is at the heart of President Xi Jinping's Deep Earth Exploration Initiative, launched in 2021. Let's pause for a moment. What do you think they'll find down there? Could it be materials formed over a million years ago, ancient rock formations that tell tales of Earth's earliest days, or even data that could help scientists predict and mitigate earthquakes or volcanic eruptions? The possibilities are endless. While these projects are incredibly ambitious, they aren't without precedent. The Soviet Union's Kola Superdeep Borehole still holds the record as the deepest man-made hole, reaching 40,200 feet, about 12,300 meters, after more than 20 years of drilling. By comparison, China's timeline to reach 36,000 feet is remarkably short, highlighting its advancements in engineering and technology. The Tarim Basin in Xinjiang is home to some of China's largest and deepest oil reserves. In this region, the state-owned energy company Sinopec has undertaken extensive, ultra-deep drilling projects, including the Shunbei oil and gas field, where an impressive 49 wells exceed 8,000 meters in depth. This drilling effort also holds the potential to provide scientists with valuable insights into the Tarim Basin's unique geological history. The basin, which gathers water from 3 surrounding mountain ranges, is believed to have formed over 200 million years ago during the closure of the Paleo-Asian Ocean. However, Edward Sobel, a geoscientist at the University of Potsdam in Germany, notes that the project appears to prioritize industrial oil extraction rather than pure scientific research. Research wells usually aim to avoid oil and gas deposits, he points out. Still, Sobel acknowledges that if the project includes activities such as collecting core samples and conducting geophysical surveys, it could yield significant scientific benefits. He emphasizes the basin's geological importance, describing it as over 1 billion years old, with stable bedrock buried beneath layers of sediment that have accumulated continuously since the Cambrian period. These strata, he notes, are comparable to the layered rock formations visible in the Grand Canyon. So why haven't other countries dug deeper into our own planet? The answer is surprisingly simple. While attempts have been made, they've faced overwhelming challenges. Back in the Cold War era, there was a fervent race to drill into the Earth, akin to the space race, but focused inward rather than outward. This deep frontier competition was a showcase of engineering ingenuity and cutting-edge innovation. The United States led the charge in the late 1950s with a group of brilliant minds from the American Miscellaneous Society spearheading the ambitious Project Mohole. The goal? To penetrate the Earth's mantle by drilling through the Mohorovičić discontinuity, or MOHO, the boundary separating the Earth's crust from its mantle, located 30-50 kilometers below continents and 5-10 kilometers beneath the ocean floor. Instead of tackling the thick continental crust, American scientists opted for a shortcut, drilling through the thinner oceanic crust. Their chosen site was off Guadalupe Island in the Pacific, where the crust's reduced thickness seemed to simplify the task. But this approach came with its own challenges. They first had to reach the seafloor before drilling could even begin. Not to be outdone, the Soviet Union launched its own endeavor in 1970, drilling on Russia's Kola Peninsula. 2 decades later, Germany joined the race with the Continental Deep Drilling Program in Bavaria, reaching depths of 29,800 feet, around 9,100 meters. However, all these projects faced a daunting reality. The technologies needed for such extreme drilling didn't exist yet. It was like designing a spaceship mid-launch. Every tool had to be invented and refined as the projects unfolded. Take Project Mohole, for example. In the early 1960s, essential drilling techniques like dynamic positioning, which stabilizes drill ships over a borehole, were non-existent. Ingenious engineers had to improvise, equipping their ships with extra propellers to maintain stability. Similarly, German engineers faced the challenge of keeping boreholes perfectly vertical and developed a solution that has since become a standard in the oil and gas industry. A reminder of how these ambitious projects often yield unexpected technological advancements. But despite their innovative efforts, these missions were fraught with difficulties. Boreholes frequently collapsed, temperatures soared to unimaginable levels, and equipment faltered under the extreme conditions. Costs ballooned uncontrollably, and political tensions often derailed progress. For instance, Project Mohole, arguably one of the boldest attempts, was scrapped in 1969 due to spiraling expenses, just 2 years before Neil Armstrong famously walked on the moon. This cancellation marked the end of America's deep Earth exploration dreams, even as the Soviets and Germans pushed forward. Now, to understand why drilling to extreme depths is so difficult, we need to revisit the story of the Kola Superdeep Borehole, the deepest hole ever drilled by humanity. Located in Russia's Pechensky district, this groundbreaking project began in May 1970 and stretched over 2 decades, concluding in 1994. Why so long? Mechanical failures plagued the effort, forcing engineers to start fresh with a total of 5 separate boreholes. Yet, despite these setbacks, The Kola Superdeep Borehole yielded astonishing discoveries. Scientists unearthed findings no one expected. At depths previously thought inaccessible, they discovered water and hydrogen. Yes, water, where the crushing pressure and heat should have made its presence impossible. Even more fascinating were the microscopic plankton fossils unearthed at depths of about 19,683 feet, approximately 6 kilometers. These remnants of ancient life were buried in layers far deeper than anyone imagined they could survive. Additionally, Russian scientists encountered water seeping into depths that defied expectations. Furthermore, beneath the continental granite, where they anticipated encountering basalt, they instead found metamorphic rock. This rock, altered by immense heat and pressure, provided critical evidence supporting the then emerging theory of plate tectonics. At the time, this discovery was monumental, helping scientists refine their understanding of the Earth's crust. Despite the remarkable insights, the Kola borehole highlights just how little we've managed to penetrate the Earth. Even at its record-breaking depth, it's barely a pinprick on the planet's surface. Why did the effort stop? It wasn't for lack of ambition, but rather because of an unexpected obstacle: heat. As the drill reached depths of 40,230 feet, around 12 kilometers, temperatures soared to 180 degrees, 356 degrees. This intense heat wreaked havoc on the drilling equipment, causing bits to wear out at an alarming rate. Continuing the project would have required costly new technology, but with diminishing returns, the funding dried up. The collapse of the Soviet Union in 1991 sealed the facility's fate. Today, the site is little more than a curiosity for tourists seeking to stand on the edge of one of humanity's boldest endeavors. Germany's continental deep drilling program, however, tells a slightly different story. Located in Bavaria, the site still retains its equipment, now repurposed for scientific measurements. Its towering drill rig has been converted into a crane, standing as a testament to human curiosity and perseverance. Meanwhile, the United States, after abandoning Project Mohole, redirected its focus to the oceans. The deep-sea drilling project, which ran from 1968 to 1983, proved to be a resounding success. This international program revolutionized geological research, providing definitive evidence for seafloor spreading and continental drift, key components of the plate tectonics theory. Its legacy paved the way for future oceanic drilling projects and expanded our understanding of Earth's dynamic crust. Still, the dream of reaching the mantle persists. If we ever succeed, the discoveries could upend our current understanding of geology, offering revelations that challenge long-held beliefs. And what happens if we actually succeed in reaching the Earth's mantle? Contrary to dramatic imaginations, there won't be rivers of molten rock surging up the borehole like a volcanic eruption. The mantle's rocks are solid but surprisingly dynamic, moving at a pace so slow it rivals the growth of your fingernails. Think of Earth like a layered cake, with the mantle as its thickest and most mysterious layer. While the crust, the surface we inhabit, makes up just 1% of Earth's volume, the mantle is the true giant. It accounts for 68% of the planet's mass and a staggering 85% of its volume, far outweighing the core's 15% share. Yet, for all its dominance, no one has ever seen the mantle directly. Unlike the liquid magma some might imagine, the mantle consists of solid rock. But under the immense pressure and heat deep within the Earth, these rocks flow, albeit at an imperceptibly slow rate. Picture the mantle as a massive lava lamp. Near the boundary with the core, rocks heat up, lose density, and rise toward the crust. Upon cooling, they sink back down in a slow, cyclical dance that can take up to 2 billion years to complete a single loop. This immense hidden movement raises countless questions about the mantle's role in Earth's geological processes. Accessing it directly perhaps through an ultra-deep borehole, would be nothing short of revolutionary, a scientific leap comparable to landing on the moon. Why is a pristine Mantle sample so coveted? It's like finding an untouched relic of Earth's earliest days. Such a discovery could unravel the planet's origin story and evolution, revealing the raw materials that shaped it into the dynamic, life-supporting world we know. Examining the Mantle's untouched composition would also help scientists refine their understanding of the physical processes governing Earth's interior. But how do we know so much about the Mantle without having ever drilled into it? The answer lies in seismic waves. When earthquakes occur, the vibrations ripple through the Earth, altering their speed and path as they pass through different materials. By analyzing these patterns, scientists can infer the density, viscosity, and even the structure of the Mantle. Earth's crust also offers other clues. For example, when massive ice sheets melt, the crust slowly rebounds upward. Measuring this process provides valuable insights into the forces and properties deep below. Even our planet's magnetic and gravitational fields tell tales of the Mantle's composition and behavior. Despite never having physically reached the Mantle, scientists have managed to study fragments of it. Some Mantle materials have been ejected during volcanic eruptions, while others have risen to the surface through tectonic collisions or emerged at mid-ocean ridges. However, these samples are far from pristine. Their interactions with air, water, and other surface elements have altered their original state, making it difficult to draw definitive conclusions about the Mantle's unspoiled nature. This is why the quest to drill directly into the Mantle remains so compelling. A sample untouched by surface conditions could answer long-standing questions about its density, heat conductivity, and seismic behavior. More importantly, it could challenge or confirm existing theories about the Earth's interior. Every piece of new information brings us closer to solving the mysteries of our planet, an extraordinary journey into the unknown. Currently, China is making bold moves on two fronts, delving deep into the Earth's crust and aiming for a lasting presence on the moon. With the initiation of two ambitious super-deep drilling projects, China is signaling its readiness to lead in uncharted territories. These endeavors, fueled by substantial financial backing and an aggressive timeline of just 15 months, could break new records and redefine our understanding of the Earth's inner workings. But could these projects extend to drilling into the Earth's Mantle? For now, we watch as China steadily progresses. While geopolitics undoubtedly play a role, these efforts are also about expanding humanity's knowledge of our planet. Each layer of the Earth we uncover holds the promise of solving critical mysteries and perhaps even uncovering revolutionary solutions like supercritical geothermal energy. Buried nearly 20 kilometers beneath the surface, this untapped energy source could transform our world. It's as potent as fossil fuels, yet as clean and renewable as solar or wind power. With a minimal environmental footprint, supercritical geothermal energy could address climate change, alleviate energy poverty, and create millions of jobs. However, accessing it demands overcoming the monumental challenge of drilling to unprecedented depths. Meanwhile, China's ambitions extend beyond Earth. On the moon, they are exploring something equally groundbreaking: lava tubes. Billions of years ago, the moon's surface teemed with rivers of molten rock, which cooled to form hardened crusts while leaving vast underground tunnels. Unlike Earth's lava tubes, those on the moon could be enormous thanks to its lower gravity. These tunnels, hidden beneath the moon's surface, offer a potential solution to one of space exploration's biggest challenges: survival. The moon's surface is bombarded by radiation, micrometeorites, and extreme temperature swings. Lava tubes, with their natural shielding and stable internal temperatures, could provide a safe haven for long-term human habitation. Data from NASA's Lunar Reconnaissance Orbiter reveals that some of these caves maintain a comfortable temperature of 63 degrees. Imagine transforming these colossal tunnels, some over a kilometer wide, into self-sustaining lunar colonies. These habitats could house living quarters, research facilities, and even farms, reducing reliance on Earth and paving the way for deeper space exploration. Beyond shelter, lava tubes could hold valuable resources. Helium-3, a rare isotope embedded in lunar rock, has immense potential as a fuel for nuclear fusion, offering nearly limitless clean energy. Additionally, water ice within these caves could be converted into oxygen, drinking water, and hydrogen for rocket fuel. These resources could make the Moon a strategic launch pad for missions to Mars and beyond. China is fully equipped to explore these tunnels. Advanced robots with 3D imaging, tethered navigation systems, and cutting-edge sensors will be deployed to map and study their interiors. These efforts could unlock secrets of the Moon's volcanic past, revealing its geological history while laying the groundwork for future colonization. We're witnessing the dawn of a new space race. This time, it's not just about reaching celestial bodies, but establishing a permanent presence. While the United States leans on private industry for rapid innovation, China's government-funded Chang'e program takes a methodical approach. With a goal of establishing a lunar base by 2030, China aims to secure its position as a global leader in space exploration. From drilling into Earth's depths to exploring the Moon's hidden tunnels, China's efforts reflect a broader narrative of ambition and ingenuity. What do you think about China's bold projects? Will they achieve their goals? And how might these ventures reshape our future? Share your thoughts in the comments below. And if you enjoyed this video, don't forget to like and subscribe.